Guys, I want to show you how to analyze a data set in a way that works across all data sets. This is what we use in data science and that sort of thing to really figure out what a data set's about. So if this is using Python, we're just importing some libraries, and we have a file here, and you can see here, this is what the file looks like. It's got a bunch of columns. Let's ignore even what it says in it. It doesn't matter. It's got 6 columns. This is the shape of it. Data frame, a DF is data frame, which is a Python, basically Excel spreadsheet called pandas. It's got 1,025 rows, 6 columns. Okay, actually gives you the data types. You can see there are 2 numbers, age and amount, but we'll get to that. So let's get a list of all the columns. These are all the columns. And now what I'm doing is I want to print out the column name, which is I, just looping through all the column names, and then giving me the number of unique values divided by the total rows. So let's run this and you'll see what I mean. So basically it's saying like this, that the name, there's 13 unique values, age has got 28, sex got 2, insurance got 11, description's got 1. So this already gives us a ton of information about this data. Let's think about this. Uniqueness is basically telling you if something's a detail or something that's a general. If you only have one piece of information in the entire spreadsheet, it's basically useless. All right, because there's nothing to compare it to. It's only good in comparison to something else. So probably row 1 is just as good as row 1,000. So that's a basically useless piece of information. Sex is what we call a binary decision, which is basically either male, female, or true or false, yes or no, 0 and 1, right? All the things we call just white and black, which is not reality. Nothing is ever really white and black. So those 2 pieces are pretty much not really going to help us. The amount, on the other hand, is obviously something very important. It's got 100% uniqueness, right? It's got 1,000 different amounts, right? So usually anything over 30, 40, 50%, this is something that's detailed. This is something which is not, it's got really high cardinality. It's not something that's we can categorize. But you can see there's some other columns, name, age, and insurance, where these look like something which are general groups, they're categories. And we're going to have to basically take these categories and sum up amounts by each category. So it's funny, it's like this. If you take data types, let's just take a new one, right? There's 0 and 1s. Right? That's what we call binary. It's either you're 0, either a 1, true or false, right? Any of those type of datas, which is not reality. Right? Anything that's white or black, or in this case black and black. But it's not, it's almost useless piece of information. Most data is on a path. Something that's a detail, that's general. That's categories. And categories are not real. There really is a line, there's a range of values going from 0 to 1. We just cut it in half and say, no, 0 or 1. Even think about it, alive or dead, which is really a decision of either it's true or false. But it's not true because we have, let's say somebody who's brain dead, or a baby that's in a womb can be alive, is partially alive, partially dead, right? So there is a range of values. We just say, oh, we like categorizing values either true or false, or 0 and 1. Almost all values are like this. They're just a range. And as you get detailed, there's more and more range of possibilities. The smaller piece of information about an object you get, the more range of values you have. I mean, think of even hot or cold, right? This is 0 degrees. This is 100 degrees, right? But we break it up into 3 categories. We say, right, high, low, medium, right? So these are totally arbitrary categories we give it. There's really just a range, and we just slice it up. We literally just cut things in pieces just to be able to categorize it. So the point is that anything that's got 13, 28, 11, which is 1, 2, or 1%, is basically a category. It's a way of splitting up information. It's each person, each age, each description. So those are basically what we call categorical values. Even though an age is not really thought of as a category, but you already know something about this data, that name, age, and insurance code are a way, a category that we can sum up the amount by. Let me know if you have any questions. Like below.